Hi everyone, Victor here again, and I welcome you to the next chapter, which is creating and managing Kubernetes components using adhoc. In one of our previous lessons, we learned some basic Kubernetes components, and in this lesson, we are also going to learn and understand some other Kubernetes components and features such as deployment, replica set, and namespace. The first Kubernetes component we're going to create is pod. And like we learned in one of the previous lessons, a pod is a collection of containers and other resources. Hence, creating a pod basically means creating or deploying a container image or images. The two ways of creating a pod in Kubernetes is by using deployment, and the other way of creating a pod is without using deployment, that is, as an individual object. Now let's break this down. A deployment is an abstraction over a pod, and using deployment to create a pod is basically the easiest and finest way of creating a pod. And the reason is because using deployment to create a pod is a way to manage the application holistically. And this is what I mean. Using deployment automatically gives you the replica set features, and with the replica set features, this simply means that you can easily create the replicas of a pod. For example, you can easily create two, three, four replicas of a pod. So with deployment, you don't have to create the replica set separately. The replica set will automatically be created and managed by Kubernetes, and part of the management also includes the updates and the likes. Using using deployment also allows you to easily do the upgrade of a pod, and one can easily roll back in case the upgrade is not compatible. So that's why using deployment to create a pod is the finest way. On the other hand, creating a pod as an individual or single object doesn't give these robust features, unlike when you use the deployment to create a pod. And of course, this is fine, especially if you need to quickly create a pod. You can create a pod as a single object. So going forward, we're going to look at how to create a pod as a single object, after which we're also going to look at how to create a pod by using deployment, and like I said, which is the better way of creating a pod. So far we've learned what deployment is. Deployment is an abstraction over a pod, and also we've also learned what replica set is. It's a feature that allows you to create the replicas of a pod. And moving forward, we're also going to learn what namespace is. But before we do that, like I said, let's see how to create a pod as a single object. So now I am on the system we configured in our previous lesson. And what I'm going to do before I create the pod is to check if there is any pod that is currently running on this cluster. And to do that, I'm going to use the kubectl client. So I'm going to say kubectl get pod or pods. So you can see that here we don't have any resource like pod running in the default namespace. So let me quickly explain what namespace is. Namespace is for organization of resources. It allows you to group your resources. So every resources you create will always be in a particular namespace. So some technology call it resource group like Azure, and some calls it project like OpenShift. OpenShift calls it project. So you might also want to see my OpenShift course. I'll be dropping the link in the description box below. By default, every command or resources we create will always be in the default namespace, except you specify otherwise. And as we go on in this course, we're going to create another namespace that is different from the default namespace. So I don't want to make things complicated for now. So as we go on, it's better we create another namespace. So let's just do with the default namespace for now. And of course, to get all the namespaces you have on the system, you're going to use the command kubectl get namespace. So this will show you all the namespaces you have on the system. And you can see that currently we have the default namespace, we have the kube node list, we have the kube public, and we have the kube system. So whenever you create a namespace and you use this command will show you the namespaces that you have on the system. Now, to create a pod without using deployment, you're going to use the kubectl command, of course. So you're going to say kubectl run, and you're going to give the pod a name. So I'm going to give this pod a name called Nginx application. So I'm going to say it should pull this image, which is the application. It should pull this image, it should pull the Nginx image. That is, it should pull the Nginx application. And of course, by default, Kubernetes always pulls image from the Docker hub. And with this that we've specified, it is going to pull the latest image of Nginx. And I must say that at this point, if you do not understand the basic container runtime like Docker or Podman, permit me to say that you don't have business learning applications that's got to do with orchestration and automation of container applications. Because if you really understand container runtime, the basic container runtime, such as Docker or Podman, you will understand what this thing is doing. So it's just trying to pull image. And of course, because we did not specify the latest tag, it is going to pull the latest application of Nginx. So having said that, I am going to be dropping the link to my Podman course and the Docker course so that you can just learn the basic. You don't need to learn all, you just need the basic, the basic knowledge of this container runtime. After you learn just the basic knowledge, then you can come back to learn Kubernetes or OpenShift or other orchestration or automation tools for containers. So let's go on to create this pod. So I'm just going to say enter. So you can see that the pod Nginx application has been created. So let's use the command kubectl get ports again. So you can see here that you can see ready is saying 0/1, which means it is not ready. And you can see status is saying container creating. So it's still creating the container. So if I run this command again, you can see that it is still trying to create this container. So it's pulling the image. Like I said, it's pulling the Nginx image or application from the Docker hub repository. So yeah, repository or registry. Yeah, so it's pulling that image. So let's check again. So you can see now that the pod has been created. You can see here it's now showing 1/1, and you can see that it is running. Oh wow. Oh wow. Sorry, my one of my applications is just popping up, so I'm going to have to dim some parts of the video. It's a very important application of mine. So all right, so to continue, you can see that this has been created and it is running. To get more information about the pod that you've created, you can use the command kubectl. So you can say describe pod Nginx app. So this will give you a lot of information about the pod. So I'm just going to clear my screen and I'm going to run this command again. I'm going to scroll up a bit because there are a lot of information here. So you can see from here kubectl describe pod, and you can see the name of the pod, which is showing Nginx, and you can also see the namespace. Like I told you, the namespace, we are working with the default namespace. We'll talk about what priority is later on, and you can see the node. Of course, it is running on this node, which is the minikube node, and you can see the start time of the pod. You can see the labels. We're also going to talk about the labels later on in this course. You can see the status of the pod. You can see that it is running. You can see the internal IP of the pod, and you can see other information. So by the time you scroll down, you would see other information about the pod. So I'm just going to, what I'm also going to do is to run this command again, which is kubectl get pod. So I'm going to say kubectl get pods. So you can see what the command is going to show to you, and it will also show you the start, the age, that is the duration in which the pod has been running. And I can also use the command -o, which is wide, to see other information about the pod. And you can see that this would also show you some other information about the pod. So this is showing the internal IP of the pod, and it's also showing the node in which the pod is running, which is minikube. So we can clear our screen. So the next activity we're going to do is to create a pod by using deployment. And before we do that, I also want us to create the same Nginx application. So what we're going to do is to delete this pod that we have created. So to delete the pod, I'm going to say kubectl delete, delete pod Nginx app. So you can see that the Nginx app pod has been deleted. And if I also say kubectl get pod, so you can see that we don't have the pod Nginx app here any longer. And of course, if I say kubectl get deployment, of course, we don't even have any deployments because we have not created any in the first place. So what we want to do now is to create a pod by using deployment. So to do that, to do that, we use the command kubectl create deployment, and we give the name of the deployment, in this case Nginx app, and then we also tell Kubernetes to pull the image from Docker Hub, and the image that is going to be pulling is Nginx. So you can see that the deployment has been created, and for you to confirm that, we can use the command kubectl get deployment. So you can see that we have one deployment here, which is Nginx app. This is the name of the deployment. And you can see that the deployment is ready. You can see that it's up to date. You can see that it's available. And you can also, of course, pass the output to a wider option. And when you do that, you can see some other information of the deployment. And for us to confirm that this deployment has created a pod, you can also say kubectl get pods. So you can see that we already have one pod running. You can see that it is ready, and you can also see the name of the pod, which is Nginx. So it's taking the prefix from this deployment. This is the name of the deployment. So it's taking its prefix from the deployment, and it also has some other names here. So this is the name of the pod that has been created with this deployment. And to get some other information about the pod or the deployment, of course, we can use the command kubectl describe pod or pods. Then we're going to say describe this pod. The name of the pod is here, so I'm just going to copy this. So you can see the information of the pod. We have some sort of information here. So let me try and scroll up so we can see the information we have. So you can see the name of the pod here. You can see that the pod is running on a default namespace. You can see the priority. You can see the status of the pod. You can see that it is running. And if you also want to get the information about the deployment, you can also say kubectl describe deployment. And the deployment is Nginx app. So you can see the information about the deployment as well. So let me try and scroll up so we can get to understand some of the information. So you can see here that this deployment is running on a default namespace. You can see the recreation time, the labels, the annotations, and the selector. You can also see the replicas of pod. So let me quickly explain what a selector is. The selector is used to connect the pod and the deployment. As you know that the pod is a different object from the deployment. So the selector is the one that is going to connect both the pod and the deployment together. So if you have some number of pods, say 1, 2, 3 pods, the selector is responsible for connecting your pods to the deployment. And you can see the replicas here. We have just one replica, just one pod, one desired, one updated, one total, one available. And if you scroll down, you would see some other information here. You can see the pod template and you can see the logs that is pertaining to the deployment. So now let's test if the Nginx application is properly deployed. And to do the test, we need the IP of the pod. And to get the IP of the pod, I can easily run the command kubectl get pods. I can also pass this output to a wide option, and then we can see the IP of the pod here, which is this IP. And if I run the command call 172.17.0.3, you can see that I am not getting any output here. And even though I get any output, I'm not going to see the kind of output I want, which is the hello or welcome message to confirm that we have properly deployed the Nginx web server. And you and I would agree that whenever you deploy a basic web server such as Nginx or Apache, when you use the call command, you will easily get the hello message or the welcome message for you to be able to verify that you have properly deployed the web server. And in this case, we are not getting that. And why is that? This is because we are leveraging on Minikube to be able to deploy our Kubernetes cluster. So Minikube is the node where our Kubernetes cluster is running, and it is running as a VM inside of Minikube. So our physical servers or VMs, they are just the external server to the Minikube node, and they are just like you using another entirely different laptop or desktop somewhere else to access the Minikube node. And you should also know that it is on this same external node that our kubectl client was installed on, so that we'll be able to interact with Kubernetes. Hence, if you run this command, call command, you can never connect to the application because the application is deployed in another node, which is Minikube, that is different from your own VM or physical server. Only except when you expose the pod to a service, that's when you can remotely, so to say, connect to an app or the pod where the application resides. And you can even also see that when you run the command kubectl get nodes, you can see the Minikube node. And when you say kubectl get pods, so I'm going to pass this output to a wide option. You can see that this pod is running on the Minikube node. You can see the Minikube node here. which is different from this your VM or your physical server that you're using to run the Minikube node. If it had been that we used this architecture, when you run this command, which is kubectl get nodes, you would have seen the name of the nodes that are listed here. You would have seen either master node 1, master node 2, worker node 1, worker node 2, worker node 3. They are just going to be listed here. And also, you would have seen the name of the node where this pod is going to be running. It can either be in worker node 1, worker node 2, or worker node 3, depending on the number of worker nodes you have in the cluster. And like we understood in one of the previous lessons, that when you run your command, of course, you would run your command from the master node, and there would be some sort of load balancing among the master nodes, and then Kubernetes would automatically deploy the pods in any of the worker node. So then you can log into the worker node where the pod is deployed in and run the call command. You would definitely see the output. So since we are using a single node cluster in our case, we will have to log into the Minikube to be able to do our test. So to log into Minikube, we can get the Minikube IP by using the command minikube IP. And to log in into Minikube, we can say SSH docker at the IP, which is 192.168.39.238. And the default username to log into the Minikube node is docker, and the default password is tcuser. And you can see now that we have been able to log in to the Minikube node. And now when I run the command call with the IP of the pod, which is 172.17.0.3, you can see that I can see the welcome message, which is welcome to Nginx. And also, don't forget that in one of our previous lessons, I said that one good thing about Minikube is that it automatically comes with the Docker container runtime by default. And you remember that we didn't even have to install the Docker container runtime on our node, that is on our external node. We just leveraged on the Minikube's Docker runtime. And that's why right here on this machine, on this Minikube node, if you do docker ps, you would see all the pods that are running in this Minikube node. So if I say docker ps, you can see that we have a whole lot of pods running on this Minikube node. You can see all the services we talked about in our first lesson. They are all running as a pod. They're all running as a container. And if you do kubectl command here, you would see that you won't be able to see any commands such as kubectl, and that is because when we installed the kubectl client in our first or second lesson, when we installed the kubectl client, we installed it on our VM, or if you used a physical node, then you must have installed it on your physical node. We didn't install it on the Minikube node itself, and that is why when you say kubectl, it will tell you command not found. So when we exit out of this node, we are going to utilize the kubectl command again to see that the kubectl client, with the kubectl client on the external node, will be able to interact with Kubernetes cluster that is running on the Minikube node. So there are quite numbers of containers here. I'm trying to look for the container we just created, which is the Nginx. So I'm just going to grep for that container. So I'm just going to say docker ps grep Nginx. So we can see the pod that we just created. you can see that it is running as a container, which is the Nginx here. And if you look at this as well, this pause, well, this pause is used to maintain namespaces. So this is the main container that is running, the main Nginx application that is running. And of course, we can also connect inside of the container. So to do that, we can just say docker exec interactive and the container ID. I need to get the container ID. So let me run this command again. The container ID is this. So I'm just going to copy this and I'm going to run the command again, which is docker exec it, then the container ID. Then I'm going to say you should use the bash shell, the sh shell, and then you can see that we've been able to log into the container. And if I do host name, of course, I'll be able to see the host name of this container. And also, if I do host name -i, I'll be able to see the IP address of this container. And of course, it's the same IP we saw before we logged into the container itself. And if I also want to do my test, even right here in the container, I can say call 172.17.0.3, and you can also see the same welcome message, which is welcome to Nginx. And this is telling you that you have properly deployed Nginx web server. So now I can exit out of the container and I can also exit out of the Minikube node. And you can see that we are back onto our external node. Okay, so now let's run some kubectl commands. Before we do that, let's also try and run the docker command here to see if it will work. You can see that it's saying that we don't have such command as docker. So I'm not going to install docker. Well, we are already leveraging on the Minikube's docker. So what I'm going to do now is to run some kubectl command. So if I want to, of course, get the namespaces on the cluster, I would say kubectl get namespaces, and then we can see the namespaces or the namespace that we have here on the cluster. And if I also say kubectl get pods, we can also see the pods that we have on the cluster. But if I want to get the particular, if I want to get the pods that are running in a particular namespace, for example, the kube system namespace, I'm just going to say kubectl get pods, then I'm going to specify the namespace, and I'm going to say kube system, and then we can see all the pods that are running on this namespace. You can see pods like the etcd minikube. We already explained what all of these services would do. And like I said, we are making use of the default namespace as of now. And as we go on in this course, we will try and group our resources and our objects in another namespace that we're going to create for ourselves. Like I have also mentioned, that using deployment to create a pod is the finest way, and because you can easily scale up or scale down the replicas of the pod, and among some other robust features. So we have created a deployment which contains replica set and a pod. So let's have some more replicas of this pod, and to do that we can just run the command kubectl scale, meaning we want to scale this pod, deployment Nginx app, which is the name of the deployment. And I can also put in the option replicas. So I want to make these replicas 4. So I'm just going to say 4. And you can see here that we have this deployment. You can see the information here, which is telling us that the deployment has been scaled. And now if I run kubectl get pods, we should have 4 pods that are currently running on this Kubernetes cluster. And you can see the name of the pods. You can see the first pod, you can see the second pod. You can see the difference in their names is just from the third octet here. And you can also see that these pods are running, they are currently running in this Kubernetes cluster. These pods are same copies and they are just inside of one deployment. And these pods will be distributed across different nodes. And in our case, we're just using a single node. So since we're running a single node cluster, you can see that when you use the option kubectl get pods wide, you would see that they are all running on just a single node because we're using a single node Kubernetes cluster, which is the Minikube. And like I've mentioned, at the beginning, we have, the architecture, the production-like architecture. You will see the nodes, say worker node 1, worker node 2, worker node 3. You will see the nodes where these ports are actually running in. And you can also see the internal IPs of the pods. You can see this one as .4, .5, .6, and this is the first one that has .3. And I tell you for free that if you log in into any of these containers, I mean just any of these containers like we did, you'll be able to successfully verify that Nginx is correctly deployed. And so again, let's reduce the quantity of those pods. And to do that, but we can just run this command again. And I'm going to say I want to reduce this to 2. And you can see that it's been scaled. And if I say get pods again, you can see that I only have just 2 pods running inside of our one deployment. And that is one of the benefits of using deployment to create a pod. Kubernetes will automatically do the scaling, and it also automatically knows which node to add the replicas of a pod to and which nodes to remove the replicas of a pod from. And these internal IPs are also automatically given to these pods by Kubernetes. More so, you shouldn't always have to log into the Minikube node or any worker node before you are able to access an application. It doesn't make any sense. It doesn't even make any sense at all. Therefore, to be able to access the pods externally, you would have to create another Kubernetes object or component called service. So in the next lesson, we will look at how to do this. So to summarize everything that we've learned, we have been able to use the adhoc command to create some Kubernetes components, and these commands are kubectl create. This will create any Kubernetes object. Kubectl delete. This will delete any Kubernetes object. Kubectl get. This will get an information about any Kubernetes object. Kubectl scale. This is used to scale pods in Kubernetes cluster. And kubectl describe. This will give you, a lot of wider information about any Kubernetes object. And finally, please subscribe to this channel, like, share, and comment. This will encourage us to do more of these videos, and you can also get updated courses on the site. So thank you for watching. I'm going to see you in the next lesson. Bye for now.